and welcome to another video for my college algebra hybrid online course. And in this video, I'm going to talk to you about linear inequalities. I'm going to start off with a real world example, just so we can kind of understand some of the terminology here. And during the video, I'm going to do a lot of examples, and as part of those examples, I'm going to teach you how to give your answer in interval notation and in set builder notation. And so these things should help us be able to do our homework for week 2. So let's start off with this real world example. So let's suppose you are working for minimum wage in White Plains, New York, which is $14 an hour. That's your minimum wage. This is what you make, and you need to pay rent on a 1-bedroom apartment. And that rent costs you $1,850. So that is actually the minimum wage in White Plains, New York, and this is a pretty cheap cost actually for a 1-bedroom apartment. If you had a 1-bedroom apartment for any less than this in White Plains, I'd be kind of surprised. So if you're paying rent, you know that you need to make at least this much money, right? You can't make less money. Your landlord's not going to like that. So what you need to do is you need to figure out how many hours that you have to work in order to get this much money. So here's a way that we can say this mathematically. I know that I make $14 an hour, and I'm going to say, I'm going to let X be the hours I need to work in a month. To make rent. That's what you need. And this is the minimum hours I need to work. So here's what we do. If I take 14 times X, what I need that to be at least 1850. That's what this mathematical symbol here means. It means greater than or equal to. You might have seen this before. And what this is telling us is that if I take 14 and I multiply it by X, I'm going to have at least 1850, maybe more. More is okay. More is okay. If I have any money left over after rent, that's great. Less is not okay. So that's what this is saying. This is saying anything I put in has to be greater than or equal to 1850. And so let's solve this little inequality here. 14x is greater than or equal to 1850. I can divide each side of this by 14. And I get x is greater than or equal to about 132.1428. That would be the math answer to this. So I need to work at least 132.1428 hours in a month to make rent. That's a lot. Cost of living's high, y'all. But your boss isn't really going to schedule you for 0.1428 hours, are they? So in the real world answer to this, I would say the real world answer is I need to work at least 133 hours per month to make rent. And that's not even including your groceries, your other bills, anything else you're doing. That's a lot. So that would be our real world answer. Now, if my boss schedules me for 150 hours, I'm good. I can still make rent. But if they schedule me for 110 hours, I'm in trouble. So this is kind of a real world application for inequalities. There's all kinds of applications you can use in budgeting in your daily life, in a lot of STEM fields, and in higher mathematics, inequalities come in a lot. So I'm going to give you some other examples of inequalities, and we can talk about the symbols used in them. So here are some examples of linear inequalities. So we could have something like x minus 15 is less than 4. We could have negative 2x minus 1 is greater than or equal to 5. We could have 4x plus 2 is less than 5x minus 2. We could have negative 5 over 6x is less than or equal to 3/4 plus 8/3 x. These are all examples of linear inequalities. What makes these linear is the same thing that makes a line linear, if you remember from our earlier video. Take a look at the variable in each of these cases. So here are all of our variables in these examples. And notice the exponent on the variable is not written. They don't write any exponent here. And what does that mean? Which means our exponent is 1. An exponent of 1 makes these inequalities linear. Okay, so that's what's making them linear. What's making them inequalities? That's what's telling us about them being linear. What makes them an inequality is actually these symbols here. And let's go through and talk about what each one of these is. Just a little review. So this inequality here is less than. Sometimes you might see it called strictly less than. And what that means is all of the numbers smaller than 4, but not including 4. This symbol here is greater than or equal to. And what it means is all numbers that are larger than 5 or equal to 5. So numbers in that set could include 5, 5.1, 10, 30. Those are all numbers that are larger than or equal to 5, but you wouldn't have 4.9, right? That's smaller than 5, so we wouldn't include that. Oh, we already did strictly less than. You know what? Let's go ahead and change this. Sorry for your notes. But let's change it so that we can talk about this symbol here. So this symbol here is strictly greater than. That strictly means it can't be equal. It has to be larger. So what this is telling us is that 4x plus 2 is strictly greater than 5x minus 2. And this last symbol that we have here is less than or equal to. So notice we have less than or equal to. That means that whatever this number is here on the left, it's smaller, or it could be the same as this number here on the right. So it's the symbols and kind of what they mean. I want to go through and solve these and talk about how we would answer these and what our answers might look like for this. So let's start with the first one. X minus 15 is less than 4. Let's work through some examples. And we'll start with X minus 15 is strictly less than 4. So you can solve these very similarly to how you solve linear equations in one variable, which means that what I'm going to try to do, my goal is to isolate X. So I'm going to add 15 to the left and right hand side of this inequality. So negative 15 and positive 15 are additive inverses. That means we're going to end up with 0 here. X minus 0 is less than. And then here when we add 4 and 15, we will get 19. And of course, X minus 0, that's the same as X. So we have X is less than 19. So what this means is any number that is smaller than 19 is an answer to this problem. So there are a few ways to write this answer. So you can write this answer in what we would call set builder notation. Where you would say, you'd write those cool curly braces and then you would say X, this long bar here, and then you would just write X is less than 19. And what this means, if you were reading this out loud, is you would say X such that X is strictly less than 19. So some examples, right? Answers that are in this set, numbers that belong to this set, are things like negative 12, because negative 12 is smaller than 19. Or you could have 0, or you could have 4, or you could have 3/4. All of these numbers are smaller than 19, so they belong to our set. So this is called set builder notation. And if you graphed your answers on a number line, if we looked at our answers graphically, we would have something like this. We would do ourselves a beautiful little number line here. And we know that 19 is an important number. So here we have 19, 20, 21. Here we have 18. I'm going to put a dot, dot, dot to show that I'm cutting some out. That dot, dot, dot means that there's numbers in between 0 and 18 that I'm just not writing. So this is our number line. Here's 0, here's negative 1, 18, 19, 20, and 21. And we know that all of the answers we're looking for are smaller than 19. So we're going to say, look, anything that's smaller than 19 is an answer. And if you were trying to shade that, you would shade that to the left. So what this is saying, when I'm highlighting here, is I'm saying 18 is an answer, negative 12 is an answer, 0 is an answer, 4 is an answer, all those numbers we listed before. In fact, any number to the left of 19 is going to be smaller than 19 on the number line. And I'm using an open circle here because 19 is not included in our answer. Why is 19 not included? Well, I tell you, I use this example in class. Can you be shorter than yourself? No, you cannot be shorter than yourself. However tall you are, that's how tall you are. So you cannot be less than yourself when you're a number. You could be less than or equal to, but you can't be less than yourself. So to show that 19 is actually not one of our answers, we use this open circle. And now I'll show you guys interval notation. Don't freak out. Some of you are already freaking out. I can feel it. I can feel the vibes. Because interval notation takes practice to read and to write, and a lot of students have some bad experiences with it. So if that's you, sit tight. We're going to have you understanding it by the end of the semester. Don't worry. So interval notation is a way to draw a picture of what's kind of happening on the number line, and it's actually the best way to give your answer. I'm going to ask you to give your answer in interval notation every time. And what interval notation is it says, look, tell me the end points and the whole region that you're talking about. So we know that we want all the numbers smaller than 19. Well, how small can we get? Negative 100, that's smaller than 19. Negative 1,000, negative a gazillion, right? It turns out we can go all the way to negative infinity. All those numbers are smaller. So this would be interval notation. And what this means here is it means oops, I'm doing it wrong. I'll tell you guys my mistake in a second. Actually, I'm going to leave it here so I can tell you my mistake. Okay. All the numbers between negative infinity and 19. Here's my mistake. Some of you might have already seen it. I used this bracket here. The bracket would mean that we're counting 19 as part of our answer, but we're not. We don't want to count 19, right? 19 is not smaller than itself. So we want to use the braces. So now this is correct. Now this means all the numbers between negative infinity and 19, not including negative infinity or 19. And how you know that we're not including these numbers is that you use the parentheses. Parentheses means don't include it. There's different reasons here. We don't include negative infinity because negative infinity is not actually a number. Because if it were a number, we could come up with a smaller number. We could say negative infinity minus 1. Infinity just means we can go as far as we want in the negative direction, and all those numbers are smaller than 19. And we don't include 19 because 19 is not smaller than itself. 19 is not smaller than itself. And that's how you use interval notation for this particular problem. Let me do another example here. I want to do one involving fractions, because I know that fractions are a little hairy scary for some of us. And I also want to do one involving negative numbers, because there's an important thing we need to remember when we're working with negative numbers here. So let's do this one. Here we have negative 5 over 6 times x is less than or equal to 3 over 4 plus 8 over 3 times x. So here's what's going to happen when we solve this guy. We're going to attack this just like we would attack. I'm going to write solve so you know that's what we're doing. Attack this just like we would attack a linear equation. We're going to try to get all of our terms involving x on the same side, and we're going to get all of this variable x isolated by itself so that we just have x is less than or greater than or whatever, something else. Okay, so the first thing I'm going to do is I'm not going to worry about these fractions. I may not know exactly how to add it, but I can start my first step. See if you guys would agree with me about your first step here. There's other first steps that would be correct, but what I'm doing is I'm trying to cancel out this 8/3 x by subtracting it from both sides of the inequality. And thankfully, I know 8/3 x minus 8/3 x is equal to 0. And you might be freaking out and saying, okay, sure, fine, do that. But Sarah, I don't know how to handle this because I don't want to find a common denominator and I'm freaked out. Okay, so take your time. We can figure that part out together. Just copy it down on the next line. An important thing for you to know about my class is, let's say you saw this on an exam. this step that I'm doing right now, partial credit, my friends. I would give you some credit because you understand what to do in terms of solving the equation. That's a good place to be. All right. So now looking at this, I know I'm in a better position because my x's are both on the same side of the inequality. But now I cannot put it off any longer. I have to address this fraction. So what I need when I'm adding or subtracting fractions is I need a common denominator. I will show you how I do it, and we can talk about it more in class. What I do is I take a look at each denominator and I factor it. So I know that 6 is the same thing as 2 times 3. And so 8 over 3x, and that's less than or equal to 3 over 4. So what I see here is that one of my fractions has a denominator of 2 multiplied by 3, and my other fraction has a denominator of 3. So I need those denominators to be common and to match. So here's what I'm going to do. I have negative 5 divided by 2 times 3x, and I'm going to subtract negative 8 over 3 times x, and let me write it really neatly here so that we can really see what's going on. I know I struggle with handwriting, guys. If you're ever confused, leave a comment and I'll try to explain what I was trying to write. And I'm going to do this to my numerator and to my denominator. Take a second and think about it. Or maybe you're like, Sarah, I got this. Good. Make sure you bring it up in group work and you help us with our fractions because they take practice. So now I have a common denominator. I have 2 times 3 and 2 times 3. Yay! And because I multiplied by 2 divided by 2, remember we talked about earlier in the linear equations variable video that a number divided by itself is equal to 1. So if 2 divided by 2 is equal to 1, what I've just done is multiply by 1 in here, which doesn't change the fraction at all. And now, if I simplify and put these factors back together, I have a common denominator for my fractions, and then I'm ready to roll. So now I have negative 5 over 6x, and I'm going to subtract 16 over 6x, and when I have fractions with a common denominator, I combine the numerator using subtraction, because that's what we're using here, and the denominator stays the same. And I have negative 5 minus 16 all over 6 times x is less than or equal to 3 over 4. This gives me negative 21 6x is less than or equal to 3/4. Phew! All right. Here's another tricky thing about inequalities. I want you to stop right here. The next step that we're going to take is going to require some special action on our part. So what we have to do is we have to isolate this variable of x. So what's happening right now is we're multiplying by negative 21 over 6x. So to address that, here's what I'm going to do. I'm going to multiply both sides of my inequality by negative 6 over 21. I'm multiplying the same thing on each side. And I'm going to show you why I do that using the left-hand side first as an example. So what happens now is I get negative 6 times negative 21 divided by 21 times 6x. And now I have 6 divided by 6, which gives me 1. I have 21 divided by 21, which gives me 1. And notice here I had a negative times a negative, which gives me a positive. So all of this reduces to just positive 1. So I'm left with 1x on the left-hand side. Nice, right? That's what we wanted to get. Here's the big cautionary tale. When you multiply or divide by a negative number, your inequality sign flips over. So right now we have less than or equal to. Should be greater than or equal to because we multiplied by something that is negative here. And we didn't even do the rest of our work. We didn't even multiply this out. So let's go ahead and do that. We'll have 3 times negative 6 divided by 4 times 21. There's lots of ways to simplify fractions. I'll show you how I like to do it. But you might have another method that you like, in which case, stick with it. So I like to break it down. I think I've told you guys this before, and fully factor my numerator and denominator, so that I end up with 3 times negative 1 times 2 times 3. That gives me these two factors here. Oh, sorry. So the 3 is coming from the 3, and then negative 1, 2, and 3 multiply together to give me negative 6. And so to get the 4, I have a 2 times a 2. And to get the 21, I have a 3 times a 7. And then I look for pairs that divide to 1. So 2 and 2 divide to 1. 3 and 3 divide to 1. And that's it. So now I have x is greater than or equal to, and what do I have left in my numerators? 3, negative 1. In my denominator, I have left 2 and 7. And so I multiply things back together, and I get negative 3 over 14. So my final answer here is x is greater than or equal to negative 3 over 14. And I want to leave us a big note here for your notes. If you multiply or divide by a negative number, the inequality symbol flips. I'm going to go ahead and tell you this is the number one mistake students make in this type of problem. This is usually what comes up. So that's something we have to look out for. In class, I'm going to ask us to figure out why this is happening. So when I ask you in class, why does this happen? What I'm looking for is an explanation. I don't want you to say, well, it's because you multiplied or divided by a negative number. I'm going to want to know why that happened. Don't just tell me the rule. We're going to figure out why together. And hopefully that's going to make a lot more sense, and we won't make this mistake quite as much anymore. So those are some examples of solving linear inequalities. Oh, but you guys probably want to see this in interval notation and such, right? I bet you do. Let's format our answer nicely. Let's graph it. Let's take a look at it and set builder in interval notation just to give you practice with that. So let's first graph this number. So we know that x is greater than or equal to negative 3 over 14. So let's draw ourselves a number line. So here I'm going to give us negative 2, negative 1, 0, 1, and 2. And I see that this is a fraction, so it's probably, and it's a fraction that 3 over 14 would be smaller than 1. So that puts this in between 0 and negative 1. I'm going to put it right here. We're going to say this is our negative 3 over 14. All right? And what I'm looking for is every number that is larger than that. So what I'm looking for is all of the numbers to the right here. So in this case, 0 is actually larger than this number. 1 is larger. 1/2 is larger. 400 is larger. So that's what this arrow means, is that we can just keep going. In interval notation, I know that I'm going to include negative 3 over 14. And I know that because of this little line underneath the sign. So that means that this is greater than or equal to negative 3 over 14. So I'm looking for all the numbers, not just that are larger, but that are exactly the same. So negative 3 over 14 is exactly the same size as negative 3 over 14. So we're going to use a bracket in the infinity symbol and then parentheses like this. So what this means is all numbers equal to negative 3 over 14 or larger than negative 3 over 14. All right, so what we've done is we've worked through some interval notation and we've talked about how to solve these type of things. I want to show you a really interesting kind of inequality. This is called a compound inequality. So in a compound inequality, you have two symbols, inequality symbols. 4 is less than 2x minus 8 is less than or equal to 10. And so what that means is that this expression, this linear expression here, is larger than 4, but it's also smaller than or equal to 10. The compound refers to the fact that we have these two inequalities switched together. You can hear my baby in the background. She's saying, "Go see mama." She just woke up from a nap. It says 4. What this means is 4 is less than 2x minus 8. And 2x minus 8 is less than or equal to 10. So normally when we work with linear equations and linear inequalities, I keep saying both sides of the statement. Here I actually have 3 different pieces. I have 3 sides of the statement. So let me solve this for you. And you can see how it works. 4 less than 2x minus 8 less than or equal to 10. So I still have the same goal, which is I would like x to be on its own. And I want all of the constants to be on either side of the compound inequality here. So now I'm going to add 8. And I'm going to add 8 not just to the middle, but also to the right and to the left. So we end up with 12 is less than 2x is less than or equal to 18. And here I have 2 multiplying by x. The opposite of multiplication is division. So I'm going to divide by 2. And I'll also divide by 2 here and here. So we end up with 6 is less than x is less than or equal to 9. That's our answer. When you write this in interval notation, it's kind of interesting. Let's graph it first so that we can get an idea of what we're looking at. So here's our number line. Let's do 5, 6, 7, 8, 9, and 10 on our number line. And then, of course, these arrows on either side show that our number line goes off to its infinity in either direction. So what this is telling us is that the number x is actually squeezed in between 6 and 9. So all of our answers are in between 6 and 9. Here I'm using an open circle for 6 because I have a strictly greater than symbol here. And I'm using a closed circle for 9 because I have a less than or equal to symbol here. And x is actually, I'll highlight in yellow, all the numbers in between 6 and 9. So in interval notation, we would write that this way. My daughter's in the background saying 6 and 9. She's trying to help you guys. This would be our answer. And what this means is all numbers in between 6 and 9. 6 is not included. But 9 is. And when you see how many English words it takes to write that out, it starts to make sense why we might need a shorthand notation. And that would be your answer. So thanks for joining me in this video. In the next video, I'm going to talk to you about absolute value and absolute value inequalities. And then there's a section I want you to read in your textbook, and you'll be ready to start your homework for this week. I hope you guys are safe and well. I really look forward to meeting you Monday. And we'll see you soon.